This video is about the process of calculating the NPV. So this is one of the engineering quiz questions from during semester in 2013, and I assume every year this is on. So we're evaluating a small project for our organisation, and I don't know if you can read this, so I shall read it out. By making a change in the process at zero upfront cost, you will increase income by $600 each year over 5 years. Assume that the money is received at the end of each year and the real discount rate is 8%. What is the NPV of this process change? Well, before you can actually calculate NPV, in my opinion, you need to understand what this is even talking about. And basically, all we're saying is that our cash doesn't have the same value no matter when we receive it. And the reason for that is if we had cash in hand today, we would get an 8% return on it. In other words, suppose we've got time 0, year 0, and we had $100, then in year 1, well, let's keep on going, might as well leave these there for the whole time. In year 1, what would we have if you put that in the bank and you had an 8% return on it? Well, after 1 year you'd have $108. Then if we left it there another year, we wouldn't have 8% from there, but we've got a compound interest. So we start with $108 and we would get another 8% interest based on the 108 starting point. So 108 times 1.08, and we'd have $116.64. So, and this keeps on going and going and going. So what you'll soon see is that we're actually going to get our cash value. This is whatever value we've got here. Cash at year N is going to be equal to however much we had at the start, which we'll call our net PV for the sake of this video. So however much we've got right now, so if we've got it now, then obviously that is our NPV, but that's not really the point. It's going to be that multiplied by 1.08 times by, so well, let's not call it 1.08 yet because we won't always have the same interest rate. 1 plus our cash rate, we'll call that R, all raised to the N. So let's see if that makes sense. So in our first year, we have $100. Right now we've got $100 times by 1 plus our cash rate of 8%. So 1.08 time to raise to the 0, which is 1, so that's $100, so that works. In year 2, we would have how much? So we'd have 100 times 1 plus 1.08 raised to the 1.08 is squared. So I've messed this up. 1.0.08. So this is actually 1.08 squared. So it's 100 times 1.08 squared. So $116.64. So that's not exactly a proof, but hopefully that you can see that this little thing here, the 1 plus R to the N, is exactly the same as compounding your interest each year. So let's just rearrange this thing. Let's rearrange this equation that we've got and say that our NPV, because in this case we don't know what we've got now, we've been given some values each year and we're trying to work out what the net present value, what would that be worth if we had it today. So just rearranging, I'm going to divide both sides by 1 plus R to the N, and you get that that's equal to the cash in a particular year divided by 1 plus R to the N, which is the equation that you saw during the lecture from Melinda. So what am I saying here? So if I have, I'm going to get rid of the other one, get rid of this one. So all this is saying is if I've got a particular cash rate that I've been given, it's got some accompanying howling, that's alright. If I've been given this value in second year, and we know that that's how much we would have if we had $100, so let's test it out. If we had $100 for our cash now, what would our NPV be? So we've got our NPV is equal to 116.64 divided by 1 plus R, so in this case 1.08 squared, and I think we just did that calculation. 116.64 divided by 1.08 squared is 100. So there you have it. So this equation here is going to give you the value now of any particular cash value that we're going to lay out or get back at some point in the future. So let's just work through this problem now. This should be fairly straightforward. I'm just gonna pause you while I delete some of this stuff. Alright, ready to do some work and finish this one off. So in year one we're told that it didn't cost us anything, so we've got $0, and then every year after that we've just got 600 coming in at the end of the year. So what I'm going to do is calculate the NPV for each one of these values, and then we'll just sum them up, and that should give us the total NPV for now. So let's see, we've got 600 is going to be our value for every single one of these. So let's work what this is going to be. It's going to be equal to 600, because it's the same each year. You would change this number for each one of the values that you had in a different scenario. And our rate is 1.08, and it's going to be to the n. So you might get different rates for different years. Sometimes we don't have that as an assumption. We just have the same rate all the time. So all we have to do is the first one's going to be 600 divided by 1.08 to the 1, which is 555.56. And then we've got 600 divided by 1.08 squared, that's going to be 514.4. 600 divided by 1.08 cubed, you've got 476.3. We got 600 divided by 1.08 to the 4. It's going to be $441.02. I don't have enough space for the last one. 600 divided by 1.08 to the 5, and that's going to be $408.35. So now all we have to do is add all these up. So 555 point, I think that was 56, plus 514.4 plus 476.3 plus $441.02 plus $408.35, which gives us $2,395.63, which is pretty close to the answer. I think we probably would have got exact answer if we had instead of done them all separately, if you just added them all up as you go and kept the exact numbers in your calculator. So I hope that makes sense. All you do with these, hopefully in a piece of paper, you're going to be a bit neater than this. sorry for my singing daughter in the background. All you do is lay out a table, work out each cost and the rate that you've got for each cost, and then discount it back to today's value, and then add them all up.